In the previous video, we have discussed the roadmap as we move forward through Module 1. Hi, I'm Errol. Welcome to the Engineering Drawing series, where we not only draw but also are keen to know. In this first lesson, the learner shall be able to explain the different types of drawings, explain the purpose of assembly drawings, explain the purpose of component drawings, explain the use of pictorial drawings, define what is engineering drawing, and explain why there is a need to study engineering drawing. Without further ado, let's start. This was the roadmap that we discussed on our previous video. Now, let's dig into the various types of engineering drawing. Here are the various types of engineering drawings. We have assembly, component, and pictorial drawings. Now let's start with assembly drawings. Shown here is an example of an assembly drawing for a shaft support. It is drawn by Kirsty Plantenberg in the scale of 1.5:1. This scale just means that for every 1.5 cm drawn, it is equivalent to 1 cm on the true size. In other words, this drawing is larger than the actual size. As you may observe, over here are the bill of materials or parts list, which includes the part numbers used to locate the parts in the drawing as represented by these bubbles over here. The part name used to identify what that part is and the quantity required. It also indicates what type of metal is used to make the part. This means part number 1 is the base, which is over here and is made of cast iron, and we need one quantity of this base as part of the assembly. Part number 3 is a post, which is over here, and we need one quantity of this post that is made of 1020 steel. While part number 9 is an M 7x1 set screw. M here stands for a metric screw that is 7 mm in diameter and has a 1 mm thread pitch that is made of steel. If you want to know more about how to identify the various types of screws, you may click on the notification displayed above. Now, these leader lines over here lead the engineer or craftsman to the location of the part, while the parts list or bill of materials will tell the trained person what that part is. As a summary, leader lines point to the part's location, while parts list or bill of materials helps in parts identity. As you may have observed, for assembly drawings a while ago, there were no dimensions indicated. No length, no radius, no measurements, only the part numbers and bill of materials. Next, it says here, bolts shall be free from burrs and sharp edges. Shown here is a picture of a burr. Burrs are undesired projections of a material beyond the edges of the workpiece, which are usually due to plastic deformation during machining. As such, this note about burrs and sharp edges talks about the surface finish of the bolt. Next, it discussed about dimensioning and tolerancing. Tolerance means how much the length, angles, or any other specifications of the part are allowed to go beyond or below a given value. That is why, normally, you will see tolerances with a plus or minus sign, just like this indication here. Here, we see 45 degrees plus or minus 2 degrees, meaning the craftsman is allowed from 43 degrees to 47 degrees. It also talked about surface roughness and the material used. As indicated here, the bolt material must be corrosion resistant. It indicates here how threads shall be rolled, the material for the washer, the weld filler material, and the coating. As such, component drawings include all details of the product, including its size, shape, material, process, tools, and equipment. Component drawing is also known as a part drawing, production drawing, or working drawing. Lastly, we have pictorial drawings. These drawings provide a three-dimensional image which help understand the shape of an object or to assist in interpreting a drawing. There are three types of pictorial drawings. We have isometric, oblique, and perspective drawings. Here are the examples of such drawings. As you may observe, these drawings are three-dimensional, meaning it has a length, a width, and a height. We will discuss isometric and oblique drawings as part of this course. As for perspective drawings, this will no longer be discussed in detail for the purposes of this course, as its applications are usually in the civil engineering and architecture fields. And those are the various types of engineering drawings. As you may have observed, we have skipped the first part in this roadmap a while ago. Now, let's go back. What are engineering drawings? Engineering drawing is a type of technical drawing that is used to clearly define the requirements for engineered items, such as views, dimensions, and necessary information about the item. This is connected to the purposes of each type of drawings explained a while ago. On another note, according to Reddy, engineering drawing is a two-dimensional representation of three-dimensional objects. To better understand this definition, let's take a look at an example. Shown here is a three-dimensional stairs. It is a three-dimensional object because it has a length, a width, and a height. But as we may observe, this three-dimensional object is drawn in a two-dimensional shape. This white surface over here. It has only a length and a width. That is what the definition means. Meaning, throughout the duration of this course, you will be drawing three-dimensional objects and its parts on a two-dimensional drawing paper or plate. Next, remember how we skipped a while ago? This is the purpose, to give weight to the reasons behind why we need to learn engineering drawing. First, more than pictures that are drawn, engineering drawings serves as a graphical language that communicates ideas and information from one mind to another. In other words, engineering drawings prepared in one country may be utilized in any other country, irrespective of the language spoken. In the context of the maritime profession, engineering drawings available on board the ship can be read by crews of different nationalities, for example, French, Japanese, or Filipino. As such, engineering drawing serves as the universal language of engineers. Second, since all of the information about an assembly or part, as explained a while ago, is included in an engineering drawing, it also serves as a contract to suppliers of that assembly or part. Last but not the least, it communicates all needed information from the engineer who designed the part to the worker who will make it, to establish the quality of the finished product expected from the worker. And those are the reasons behind engineering drawing. To recap, in this lesson, we explained the different types of drawings, which are assembly drawings, component drawings, and pictorial drawings. We also explained the purpose of assembly drawings, which is to be able to assemble or put together the parts, as it indicates the location and identifies each part that is included in the assembly. We also explained to visualize the object and interpret it. We also defined engineering drawing as a type of technical drawing which indicates the various details of an assembly or part. And lastly, we explained why we need to study engineering drawing, since it serves as the universal language of engineers despite the different nationalities and language spoken. It serves as a contract and basis for quality. That would be all for this session, and our next lesson will be about the various types of lines used in engineering drawing. Thank you for watching this video, and don't forget to subscribe, like, and ring that notification bell. And as always, I'll see you on our next one.